Hello, welcome to today's lesson on section 5.1. The topic of this section is use properties of exponents. So what I'm going to do is make a table. We have the property name, we'll have the definition of the property, and then we'll have an example. So for property name, the first one we'll talk about will be product of powers, which will look something like this. So that's just going to be x to the m plus n. And by the way, I should actually backtrack here. When you have something like this, this whole thing is called a power. That right there is the base. And that right there is the exponent. So x at m, the whole thing is called power. X is the base, m is the exponent. So coming back to the properties, product of powers, when you have two powers, that's one power to another power, that are being multiplied, that's why it's called product of powers, and the bases are the same, we're allowed to add the exponents. So here's an example. What if I have 2 squared times 2 cubed? That'll be 2 to the 5th power. The reason why that's the case is because 2 squared is 2 times 2. 2 cubed is 2 times 2 times 2. And of course it's a total of 5 2's. That's why I have 2 to the 5th power. For the next one, that will be called power of a power. So here I have a power, x to the m, and say I raise that to the nth power. That's going to equal x mn. So if that's the case, we're allowed to multiply the exponents. So 2 squared cubed will be 2 to the 6th power. In this case, you have 2 times 2 occurring 3 times. And then count it, that'll be a total of 6 2's. Next will be power of a product. And the way that works, if you have two numbers being multiplied together like a and b, and you raise that product to a power like m, it's like you can distribute that exponent to both a and b. So for example, if I had 2 times 3 raised to the 2 power, it's the same thing as saying 2 squared times 3 squared, which of course would be 36 if you worked it out. Also 2 times 3 squared, 6 squared, you do get the same thing. That's also 36. So you know it works. Negative exponents. We'll see this a lot throughout the year. If you have a to the negative m power, that will also be 1 over a to the m power. So for example, I have 2 to the negative 3 power, that's 1 over 2 cubed. So negative exponents just means you you flip over the base, or basically you make it a fraction. Of course, we know that's 1/8. So I'm sure you've seen that before. 0 exponent. Anything raised to the 0 power is always going to be 1. So 2 to the 0 power equals 1. So far we've now covered 4 properties. 5 properties. Let's do another one. Quotient of powers. So just like earlier we had product of powers. What if I take 2 powers, x to the m and x to the n, and subtract them? Or sorry, take 2 powers and divide them, then I subtract the exponents. So if I have like 2 to the 5th power over 2 squared, that would be 2 cubed. Which makes sense, because 2 to the 5th is 32, 2 squared is 4, 32 out of 4 is 8, 2 cubed is 8. Okay, last property, and then we'll do some examples. Power of a quotient. Just like the second one we did with, third one, power of a product. If you have 2 numbers being divided and you raise that to an exponent, it's like distributing that to both. So for example, if I had 2 cubed raised to the 2nd power, you can call it 4/9. So stuff that should be reviewed, you should already know. So let's move on to some examples. And instructions for each example will simply be to simplify. Simplify each expression. So we'll do a total of 6 examples. We've got a few more here. Okay, actually I take it back, we'll only do 4 examples. I'll be a nice guy. Okay, so for the first example, it should be pretty straightforward. So in this case, I'm using the power of a power. So you distribute that 5 to all parts of that expression. So it goes 2 to the 5th, x5, y15, or 32, x5, y15. For the next one, in this case I'm actually going to be using the product of powers. Well, of course 2 times 4 is 8, and x3, x5 become x8. Here I have a negative exponent, so we distribute that first. So 3, negative 1, x, negative 1, y2, or 4x. Then I can take care of the negative exponents. So the 3, negative 1, x, negative 1 go in the bottom, making it 12x squared. And we get x squared because x negative 1 goes in the bottom, and there's already an x there to begin with, so the 2x's become x squared. And here's the last one. If I take care of the negative exponents, I'll have x11, y squared, 8 times x3, 2 squared, y4. Then if I combine stuff, x11, x3 become x14. 2 squared is 4, 8 times 4 is 32. And the y squared and y4 become y squared at the bottom, because I subtract the exponents, which is 2 minus 4 is negative 2, but since negative stays in the bottom. And that's how we do that one. So that takes care of section 5.1, and I'll see you guys on Friday. Goodbye.